In this session, we will be discussing about Amazon CloudWatch. So without any delay, I'll walk you through the topics which we will be discussing today. Firstly, we will see what Amazon CloudWatch is and why do we need it. Then we'll discuss certain Amazon CloudWatch concepts. Moving on, we'll take a look at two most important segments of Amazon CloudWatch, which are Amazon CloudWatch events and Amazon CloudWatch logs. And finally, to make this all more fun and interesting for you, I've included a demo as well. So let's get started. First, let us try to understand why we need cloud-based monitoring with a couple of scenarios. In our first scenario, consider that you've hosted a messenger app on cloud and your app has gained a lot of fame, but lately the number of people using your application has gone down tremendously and you have no idea what the issue is. Well, it could be due to two reasons. Firstly, since your application has complex multi-tier architecture, monitoring the functionality of every layer by yourself will be a difficult task. Don't you think? And secondly, since you're not using any kind of monitoring tool here, you wouldn't know how your application is performing on cloud. Well, one solution for that is to employ a monitoring tool. This monitoring tool will provide you insights regarding how your application is performing on cloud. And with this data, you can make necessary improvements and you can also make sure that your application is in par with today's customer needs. And definitely after a while, you'll notice that the number of people using your application has increased. Moving on to our next scenario, let's say your manager has assigned you with a project and he wants you to make this project as cost effective as possible. So as you can see in this project, you're using 5 virtual servers which perform highly complex computations. And all these servers are highly active during daytime. That is, they handle most traffic during daytime. But during nighttime, the servers are idle. By that I mean the CPU utilization of these servers during nighttime is less than 15%. And yet, as you notice here, in both the cases, you are paying same amount of money. You have to notice 2 points here. Firstly, all your virtual servers are underused during nighttime. And secondly, you are paying for the resources which you're not using. And this definitely is not cost effective. So, one solution is to employ a monitoring tool. This monitoring tool will send you notification when these servers are idle and you could schedule to stop the servers on time. So guys, this is one way to make your project most cost effective and avoid paying unnecessary operating costs. Let's consider another scenario for better understanding. So let's say I have hosted an e-commerce website on cloud and during sales season, many customers are trying to access my website, which is definitely a good thing. But for some unfortunate reason, application downtime has occurred. And you guys have to remember that I'm not using any kind of monitoring tool here. So it will be difficult for me to identify the error and troubleshoot it in reasonable amount of time. And it's quite possible that in this period, my customer might have moved on to different website. So you see that I've lost a potential customer here. So if I've had a monitoring tool in the situation, it would have identified the error in earlier stages itself and rectified the problem. Well, I could have easily avoided losing my customer. So I hope guys with help of these use cases you were able to understand as to why we need cloud-based monitoring. So let me just summarize what we've learned till now. We need monitoring firstly because it provides a detailed report regarding performance of your applications on cloud. And secondly, it helps us to reduce unnecessary operating costs which we are paying to the cloud provider. Moreover, it detects problems at earlier stage itself so that you can prevent disasters later. And finally, it monitors the user's experience and provides us insights so that we can make improvements. So well guys, in this session, we will be discussing about one such versatile monitoring tool called Amazon CloudWatch. Amazon CloudWatch basically is a powerful monitoring tool which offers you a most reliable, scalable, and a flexible way to monitor your resources or applications which are currently active on cloud. It usually offers you with 2 levels of monitoring, which are basic monitoring and detailed monitoring. If you want your resources to be eligible for basic monitoring, all you have to do is to sign up for AWS free tier. In basic monitoring, your resources are monitored less frequently, like say every 5 minutes, and you're provided with a limited choice of metrics to choose from. Whereas in detailed monitoring, all your resources are monitored more frequently, like say every 5 minutes, and you're provided with a wide range of metrics to choose from. But if you want your resources to be eligible for detailed monitoring, You'll have to pay a certain amount of money according to AWS pricing details. Now, let's have a look at few monitoring services offered by Amazon CloudWatch. Amazon CloudWatch, firstly, it provides a catalog of standard reports which you can use to analyze trends and monitor system performance. And then it monitors, stores, and provides access to system and application log files. Moreover, it enables you to set up high resolution alarms and send notifications if needed. And Amazon CloudWatch also sends system events from AWS resources to AWS Lambda functions, SNS topics, etc. So if you have not understood any terms which I've used here, don't worry, we'll get to know more about these terms as we progress through the course of this session. Earlier, I mentioned that Amazon CloudWatch allows administrators to monitor multiple resources and applications from single console. These resources include virtual instances hosted in Amazon EC2, databases located in Amazon RDS, data stored in Amazon S3, elastic load balancers, and many other resources like auto-scaling groups, Amazon Cloud Trail, etc. So guys, now let's try to understand Amazon CloudWatch a little deeper. Firstly, we'll have a look at few Amazon CloudWatch concepts, and then I'll explain you how Amazon CloudWatch actually operates. So it's metric. A metric represents a time-ordered set of data points that are published to cloud. So what I mean by that is, suppose let's say you have three variables x, y, and z, and you have created a table which has values of x with respect to y over a period of time. In this scenario, the variable x which you have been monitoring till now is a metric. So you can think of metric as a variable which needs monitoring. Next we have dimensions. Let's consider same variables x, y, and z. Previously you had created a table which has values of x with respect to y. Now let's create another table which has values of x with respect to z. So basically we have two tables which describe same variable x but from two different perspectives. These are nothing but dimensions. So basically a dimension is a name value pair that uniquely identifies a metric. And Amazon CloudWatch allows you to assign up to 10 dimensions to a metric. Then you have statistics. Previously we had created two tables which had values of x with respect to y and as well as z. You can combine data from these tables like to create a chart or maybe plot a graph for analytical purposes. This combination of data is nothing but statistics. Statistics are metric data aggregations over a specific period of time. Then you have alarm. Let's say you have been monitoring this variable x for some time now and you want a notification to be sent to you when the value of x reaches certain threshold. All you have to do is set an alarm to send you notification. So basically, alarm can be used to automatically initiate actions on your behalf. Now that you have clear understanding of concepts of Amazon CloudWatch, let's see how Amazon CloudWatch operates. Amazon CloudWatch has complete visibility into your AWS resources and applications which are currently running on cloud. So firstly, it collects metrics and logs from all these AWS resources and applications. And then by using these metrics, it helps you visualize your applications on CloudWatch dashboard. Moreover, if there is some sort of operational change in AWS environment, Amazon CloudWatch becomes aware of these changes and responds to them by taking some sort of corrective action, like maybe it sends you a notification or it might activate a Lambda function, etc. And finally, it provides you real-time analysis by using CloudWatch Metric Math. So if you're wondering what CloudWatch Metric Math is, it is a service which integrates multiple CloudWatch metrics and creates a new time series. And you can view this time series on CloudWatch dashboard as well. So working this way, Amazon CloudWatch provides you with system-wide visibility. It even provides you actionable insights so that you can monitor your application performance. Moreover, it allows you to optimize resource utilization if needed. And finally, it provides a unified view of operational health of your AWS environment. So I hope that by now you know what Amazon CloudWatch is. So now let's try to understand how Amazon CloudWatch works with help of a demo. So guys, this is my AWS console. Let's say AWS Management Console. And the services which you can see on the screen are the services offered by Amazon AWS. But in this demo, we're going to use only few services. Let's say CloudWatch, and then you have EC2 and a service called Simple Notification Service. And when I click on EC2, it takes me to EC2 dashboard where you can see that I have 4 instances which are currently active. You know that here in this demo, I'm supposed to get a notification saying that CPU utilization of my instance is less than 25%. For me to receive a notification first, I'll have to create a topic and subscribe to it with my email ID. So let's explore a service called Simple Notification Service, where you can create a topic and subscribe to it. Once you reach SNS dashboard, click on topics option on the navigation pane and click a create new topic. Give your topic a name. Let's say CW topic, and give the display name as well. Let's give the same name and click on create topic option here. You can see that I've successfully created a topic. Now click on the topic which you have created and select actions and subscribe to topic option. Well, I want notification to be sent to me in form of email. You have different options as well in form of Lambda function or JSON, etc. But I'm going to choose it as email and give my email ID, which is here, and then click on create subscription option. So now whenever AWS console wants to send me a message, it will send to the email ID which I used to subscribe the topic. Now let's go back to CloudWatch dashboard. So guys, this is my CloudWatch dashboard and you can see different options on navigation pane. Firstly, I have dashboard where I can view all my metrics at same place. Then you have alarms, which shows the list of alarms which you have configured. And then you have events and logs, which we'll be exploring later. Our topic of interest is the last one, which is metrics. Select the metrics option here and then choose EC2 and then per instant metrics. When you do that, a list of metrics will be shown to you like network out, CPU utilization, network packet in, network packets out, and various other metrics for various resources which are currently active on your cloud. So, but we are interested only with CPU utilization. So I'm going to type that here. Well, it shows the list of instances which are active on my cloud. And I'm going to choose Windows 2 instance and then click on graph metrics option here. Okay, let's select Windows 2 only. And then on the right side, you can see you have a alarm button. When you click on that, a dialog box will be open where you can configure your alarm. Firstly, let's give alarm a name. Let's say low CPU utilization and a brief description as well. Let's say lower than 25%. Lower than 25% CPU utilization. Now I'm going to set the threshold, which is less than 25% in this case. And on the right side, you can see a period option. If your resources are eligible for basic monitoring, this period option by default is 5 minutes. And if your resources are eligible for detailed monitoring, it's usually 1 minute. And when you scroll down, you can see a send notification to option here. So select the topic which you have previously created. That will be C topic in my case, and then click on create alarm. Well, there is some error. Okay, it says there's an alarm already with this name. So let's give it another name of my instance. Now let's try again. And when you click on this alarm button and click on refresh option here, it says that I've successfully created a alarm. Here you can see that low CPU utilization of my instance. And when you click on that, it shows you all the details like description, threshold, and what action it is supposed to take when alarm is configured and all the details. So guys, try it out. It'll be easy for you to understand CloudWatch console much better. Okay guys, now you know what Amazon CloudWatch is, what it does, and the way it operates. But to understand the capability of Amazon CloudWatch completely, we should be aware of two important segments of Amazon CloudWatch, which are CloudWatch events and CloudWatch logs. So let's discuss them one by one. Firstly, we have Amazon CloudWatch events. Consider the scenario. Let's say you've created an auto-scaling group, and this auto-scaling group currently has terminated an instance. So you can see this as some sort of operational change in AWS environment. When this happens, Amazon CloudWatch becomes aware of these changes and responds to them by taking some sort of corrective actions. Like in this case, it might send you a notification saying that your auto-scaling group has terminated an instance, or it might activate a Lambda function which updates the record in Amazon Route 53 zone. So basically what Amazon CloudWatch events does is it delivers a real-time stream of system events that describe change in your AWS resources. Now let's have a look at few concepts related to CloudWatch events. Firstly, we have event here. An event indicates change in AWS environment, and AWS resources generate events whenever the state changes. Let's say you have terminated an active EC2 instance. So the state of this EC2 instance has changed from active to terminated, and hence an event is generated. Then you have rules. Rules are nothing but constraints. Every incoming event is evaluated to see if it has met the constraint. If so, the event is routed to target. Target is where the events are handled. Target can include Amazon EC2 instances or a Lambda function or an Amazon SNS topic, etc. Now let's try to understand Amazon CloudWatch events better with help of use case. In this use case, we are going to create a system that closely mimics the behavior of dynamic DNS. And for those who don't know what dynamic DNS is, let me give an example. Let's say you want to access internet at home, then internet service provider assigns you an IP address, but since internet service provider uses different kind of online systems, this IP address keeps changing. Because of which it might be difficult for you to use this IP address with other services like webcam, security camera, thermostat, etc. So this is where dynamic DNS comes into picture. What dynamic DNS does is it assigns a custom domain name to your home IP address. And this domain name is automatically updated when IP address changes. So basically, dynamic DNS is a service that automatically updates a name server in domain name system. And Amazon offers you with a similar kind of service called Amazon Route 53. So in this use case, we are going to update Amazon Route 53 whenever an Amazon EC2 instance changes its state. Now let's see how the use case actually works. This use case precisely works this way. So whenever an EC2 instance changes its states, Amazon CloudWatch event becomes aware of these operational changes and it triggers a Lambda function. This Lambda function uses different kind of information regarding the instance like its public and private IP address, and it updates a record in appropriate Route 53 hosted zone. So let's say you have an EC2 instance and you have terminated the instance. So Amazon CloudWatch events become aware of this and it triggers a Lambda function. And this Lambda function deletes the record from Amazon Route 53. Similarly, if you have created a new instance, again Amazon CloudWatch events become aware of this and it triggers a Lambda function, and this Lambda function creates a new record in Amazon Route 53. I hope you have understood what Amazon CloudWatch events is and what it does. Now let's discuss how Amazon CloudWatch events works with help of a demo. So in this demo, we will schedule to stop and start EC2 instances with help of Lambda function and CloudWatch events. So let's go ahead with demo. So guys, you can see that I have 4 instances which are currently active. First, I'm going to create a Lambda function which is going to stop my Windows 2 instance. And you guys need to know that for Lambda function to do that, we need to assign permission. So Amazon provides you with a service called IAM, which is Identity and Access Management, where you can assign permissions. When you search for IAM in the tab, it shows you the service. Select that. And on IAM dashboard, on the navigation pane, you can see a policies option here. Select that and click on create policy option. First, it's asking you for a service here, which will be EC2 in our case. Click on EC2 function, then actions, which will be to start and stop my EC2 instances. So let's search for start instance. Well, a predefined function is already there, so you can choose that. Then you have stop instance. Again, select that. And then I want this to be eligible for all the resources. So I'm going to choose all resources here and click on review policy option. Let's give our policy a name, that is to start and stop EC2 instances, and description as well. A brief description, let's say to start and stop instances. And now click on create policies. It's taking a while. So I've successfully created a policy here. Next, we have to assign this policy to Lambda function. So click on roles here, then click on create role, choose Lambda function here and click on next permission. Search for the policy which we have created earlier, that is to start and stop. I found the policy, select that and click on next review option. It's asking for a name. Let's give a name. Start, stop instances and click on create role. I've successfully created a role. So what we have done here is we have assigned permission for Lambda function to control EC2 instances. Now let's create a Lambda function. You can search for Lambda in the search tab and there click on create function. Give your Lambda function a name. Let's say to stop instance. and select the role which you have previously created and click on create function. You can see that I've successfully created an Lambda function. And now I'm just going to copy the code to stop EC2 instances here. I'm going to select this and paste it over here and make sure to save it. As you can see here in this function, it asks for instance region and instance ID. So let's configure the details. Let's give it as stop instance. And here you'll have to insert instance region and ID. Instance region and instance ID. Now we'll have to copy the instance region and ID of the instance whichever we need. So let's go to EC2 dashboard here. Now let's say I want my Windows 2 instance to be stopped. This is the instance ID which I'm going to paste it over there. Similarly, instance region now. Well, in this case, I'm choosing Windows 2 instance. You can choose whichever instance you want to stop. Once you're done that, you click on create option here. Test the configuration details. When you scroll down, you can see the execution results here. It says that my instance has been successfully stopped. Let's go and check in the EC2 dashboard. Here on the EC2 dashboard, I'm going to refresh it. And you can see that my Windows 2 instance has successfully stopped. Now we'll create another Lambda function which will restart this function. Again, the same, search for Lambda function in the search tab and click on create function option. It asks for a name, so let's say start instance, and choose the role which you have previously created and click on create function. Again, you'll have to paste the code to start the instances over here and click on save option. Let's try to configure this. Let's name it as start instance. And again, it asks for two attributes which are instance region and ID. Now all we have to do is copy the instance region and ID here like we did earlier. Let's go to EC2 dashboard and copy the instance ID and region. Well, you guys can see that here my Windows 2 instance has been successfully stopped. Now I'll copy this and paste it over there. Similarly, instance region as well. And click on create option. Now test the configuration. And when you scroll down, you can see that my instance has successfully restarted. In the EC2 dashboard, I'm going to refresh this. Well, my Windows 2 instance is on its way to get restarted. Till now, I've used Lambda function to start and stop my instances. But now I'm going to automate this process with help of Amazon CloudWatch. So let's go to CloudWatch dashboard here. Well, it's taking a while to load. Then choose events option and click on create rule. So here we're going to schedule to stop my instances every day at 6:30 p.m. and to restart this instances every day at 6:30 a.m. So click on schedule. If you want to know more about cron expressions, you can visit Amazon documentation. So let me show you. It has 6 fields. Firstly, it's minutes, then you have hours, then day of month, day of week, and year. We're concerned only with minutes and hours because we want our instances to be start and stopped every day, every month. So let's give the details. So if you're going to create a rule to stop the instance, let's say 6:30 in the evening, 30 minutes and 18, which is nothing but 6 p.m. And then rest all, you don't have to mention anything. When you give a proper cron expression, sample timings will be provided to you. You can see here the rest of the sample timings. And now let's add a target function, which is Lambda function in our case, and select on stop instance function and click on configure details. Give your rule a name. Let's say stop my EC2 instance, and description to stop my EC2 instance at 6:30 p.m. every day, and click on create rule here. You can see that I've successfully created a rule to stop my instance every day at 6:30 p.m. Now let's create another rule to restart this instance every day at 6 a.m. in the morning. Again, the same. Choose the schedule here and cron expression, which will be 6 a.m. in the morning. Again, the sample timings are shown here. Then let's add target function, again lambda function, and select the function that is to start instance and click on configure details. Let's name it as start my EC2 instance and description as to start my EC2 instance every day at 6 a.m. and click on create rule. So now we have successfully created two rules to start and stop the EC2 instances at 6:30 p.m. and 6:30 a.m. respectively. So what we have done is we have saved our time here. We have automated the process of stopping and starting EC2 instances. So try it on yourself. It'll be easier for you to understand. So guys, now let's discuss our next topic, which is Amazon CloudWatch logs. Have you guys heard of log files? Well, log files are nothing but detailed record of events that occur when you're using your AWS environment. You can view your log files on your on-premise server as well. Search for an app called Event Viewer, select the app and click on Windows Logs and select Systems. A list of log files will be shown to you. When you choose a particular log file, all the details regarding that log files will be shown, like the number of keywords, the login time, number of hours the file has been logged onto, and various other details. Similarly, you have log files created when you use AWS environment as well. So you can consider these log files as a data repository. Most of the metrics are generated from these log data. So whenever a metric is generated, a part of data is extracted from this log data. So you're designing metrics according to your like by choosing a part of data from this log data. So basically these log files are what you call a primary data storage place. And Amazon CloudWatch logs is used to monitor, store and access log files from AWS resources like EC2 instances, CloudTrail, Route 53, etc. Let's try to understand CloudWatch logs better with help of some features. Firstly, you can use Amazon CloudWatch logs to monitor your application and system log files. Let's say you have made a lot of errors but trying to deploy your application on cloud. In this scenario, you can use CloudWatch logs to keep track of your errors and send a notification to you when the error rate increases certain threshold so that you can make avoiding errors again. Then you have log retention. By default, logs are kept indefinitely. But CloudWatch provides you with an option where you can set the period between 10 years to 1 day. Then you have log storage. You can use CloudWatch logs to store your log data in highly durable storage. And in case of system errors, you can access raw log data from this storage space. And then you have DNS queries. You can use CloudWatch logs to log information about the DNS queries that Route 53 receives. Now let's have a look at few concepts regarding CloudWatch logs. Firstly, we have something called log event. So log event is just a record of activity that has occurred in AWS environment. It's straightforward. Then you have log stream. A log stream is a sequence of log events that have same source. Then you have something called log group. Log group defines group of log streams that has same monitoring and access control settings. By default, you have to make sure that each log stream belongs to one or the other log group. Guys, now let's try to understand CloudWatch logs better with help of this use case. In this use case, we are going to use Amazon CloudWatch logs to troubleshoot the system errors. You can see that I have three instances here and a CloudWatch agent which is monitoring all these three instances. So what CloudWatch agent does is it collects custom level metrics from all these EC2 instances, and then all these metrics and logs collected by the agent are processed and stored in this Amazon CloudWatch logs. Amazon CloudWatch logs then continuously monitors these metrics, as you can see here. By then, you can set an alarm which will send you notification when some sort of error occurs in the system. So whenever you receive a notification saying that some sort of error is there in your system, you can access the original log data which is stored in CloudWatch logs to find the error. So this is how you can use Amazon CloudWatch logs to troubleshoot the system errors. So basically you are having a look at original data so you can solve your problems faster and quicker.